good to be in Brisbane. It's much warmer here than back home in Christchurch, but I'll get used to it. I'm Sam, I'm CTO at Custom D. And I wanted to start today by asking you a question. How often do you guys deploy? How often do you deploy things into production? Put your hands up, if you deploy between once a week and once a month. Cool. And how about those of you who deploy between, say, once a day and once a week? Nice. And how about those who are comfortable deploying at 5 p.m. on Friday, or whenever you like? It's good to see so many hands go up. You guys can probably go home. You don't need to listen to this talk. Dora is a division of Google Cloud, and they're the DevOps Research and Assessments group. And they do a regular survey and publish a report around organizations' DevOps readiness. And they have kind of made these sort of groups or cohorts. They've found that teams that deliver between once a week and once a month fit into this sort of medium and low range of DevOps maturity, right? So these groups tend to have a failure rate for their deployments of between 15 and 64%. So, you can imagine if you're deploying once a month and over half of your deployments are failing, that's pretty serious. And not only that, but these groups, medium to low, have a recovery rate, a time to recovery of about 1 day to 1 week from a production, failed production deploy. So, that's huge. Now, looking at the high group, 1 day to 1 week, 10% of their deployments fail. So, they're deploying more regularly, but failing far less. And their recovery rate is even better, less than 1 day. So that's pretty cool. And then you look at the elite group, we've got the on-demand deployments, those of you who like to deploy on Fridays. And say, what the hell? Let's go. But there's a good reason for that. Their recovery rate is less than an hour, and that tends to be more in the minutes, minutes up to an hour. So how did we get here? How did we get such a big split between low performing teams and elite performing teams in terms of their DevOps maturity? It started a long time ago. Back in the olden days, we had to write software to physical media, and you had big factories which would produce these disks and write all of the software to that media, and then they'd package it up and put it in boxes and put it on trucks or shipping containers and send it out to physical stores where people had to go and pick them up off the shelf and take them to the checkout and go home and then install it. So, you can see there's a lot of cost, time, and effort involved in that. And so this pushed release cycles out a long time. You wanted to build your software, you wanted to, make big changes, you wanted to test it really thoroughly before you deployed it. But, as we know, you deploy something, you've tested it really well, and, a user uses it in some novel way that you'd never expected, and something breaks. So, with these physical disks, they had no way to ship new versions of software. You were kind of stuck until you spent all that money again to rewrite all those disks and ship them all out. Fortunately, in the sort of 2000s, early 2000s, broadband internet was becoming more widespread. We could get over-the-air updates. You'd load a web page, and all of a sudden you were looking at the latest thing. You had things like Windows Update, and then later on with mobile devices, app stores, all that sort of thing. So users' expectations changed around that delivery of software. They wanted things faster, they wanted things to be updated more regularly and all that sort of stuff. So, later on to kind of support that, you had the sort of rise of the DevOps philosophy, the and the tooling to support all that. So you had this convergence of the philosophy, the new tech, and the process evolution. And we've sort of, arrived today at a point where we've got all of this, amazing, wonderful tooling, especially in the Laravel community. You've got things like, Sail, you've got your local development environments, you've got Laravel Cloud coming soon. You've got all these, really great tools that you can ship software really fast and reliably. So I just want to explain a little bit about continuous integration and continuous delivery. It's a fundamental pillar of the DevOps philosophy, right? One of the key things is, automation. And you do automation to be more productive and to be more consistent, to avoid human error. So making things more reliable and faster to turn around. And you want things to be faster to turn around because you want to accelerate feedback loops, right? You want to test what you're doing. You want to deliver things quickly so that you can get feedback and iterate on that feedback from your end users or from your other developers. So the next thing is that is what Michael touched on this morning around incremental improvements, right? So this philosophy is that you make small incremental improvements over time and improve things every step of the way. So you're always kind of thinking, how can I make this better? How can I automate this? How can I improve this sticking point in my process? And, all those little changes, those ripples, build into those big waves and, you end up with a much better solution down the line. So continuous integration, I like to think of this as the merge part. That's where you get the idea here is to get your code from your development environment back into where your team can interact with it and they can start, working with it and building with it, right? And, whether your team is, your own company or whether you're working on open source software, you want to be able to get things as soon as you can into the hands of other developers who can start building on that. And, small merges are faster to do and they result in fewer, merge conflicts and that sort of stuff. Continuous delivery, so that's where you take your code and you deliver it, you share it with your users. And again, the idea is that large deploys have more in them. They're more risky. So the longer you take to, the longer you spend building something, the more changes you've made, the riskier it is to deploy that and the more issues you're likely to have. So, we found this really important for my company. We're a custom software shop, and we work a lot in the fintech, insurtech space. We work with small to medium businesses where, the software that we're producing for them is often the core of their business. It's really integral to what they do, and if something goes wrong with a deployment, then that's their business on the line. They're not making money, or, they get a bad rap with their customers. So, this philosophy made a lot of sense to us because we need really robust delivery for them. So I'm going to go back about 15 years again and talk a little bit about our DevOps journey. So we started, using straight PHP. We were really naive. We had no Git. In fact, I remember sitting at my desk, writing code, and I had a notepad beside me where I'd jot down the name of the file that I was changing so that I could remember which files to copy over FTP onto the production server while I quickly, crossed my fingers, hope no one was using the site and renamed index.php to indexold. And, obviously that has its problems, right? And we knew something had to change from that. But change, takes time, not just, trying to figure out how to do that better, trying to build the tools to do that better, but there's also cultural change. You've got to bring everybody in the organization along for the ride with you. So, obviously our first move was to introduce Git, introduce version control. But even then, we had, big differences between our production environments and our development environments. We were installing Apache, PHP, MySQL directly on Mac OS, and every time the OS updated, it broke our dev setup. We had to, spend a couple days trying to fix things, not doing actual valuable work. So we, at the time, containerization didn't exist, and so we built a virtual machine which had, the same environment that we had in production. So we built a shell script, a big giant bash script that set up the server just the way we liked it. And we built a deploy script which would take, our git tag and deploy that to the server, make sure things like, over time we added things to make sure that PHP alt cache was cleared, that virtual host templates were updated, that FPM configuration was done properly. So we had all of this kind of baked into the script over time. But then complexity reared its ugly head. We had more customers doing more projects, and we had legacy, so we had people on different versions, so we had to run, multiple versions of PHP, or FPM, or multiple different containers, and we had to switch between, or not containers, virtual machines. We had to switch between them all. And still, using parallels, every time our OS updates, we broke our dev setup again. Like, we had to wait 6 to 9 months for Parallels to update to support the new OS and all that sort of stuff. So we got to a bit of a crossroads, and by this stage, this was about 10 years ago, there were some new tools on the market. So we adopted GitLab, and it had, at the time, one of the best CI/CD processes. And we switched to using containers in our local development environment. And, one of the kind of critical things that we did at that time was introducing merge requests. So GitHub calls them pull requests, GitLab calls them merge requests. But we started doing actual proper merge reviews where we'd have a developer do the work and somebody else who knew the project well testing it and reviewing the code. Now, obviously, all of that takes time, and one of our goals is to reduce the time taken to get code from development into our main or trunk branch. And I don't know about you, but if you raise a merge request and it stays there for a week or even a few days, you get something like this. You might be working on a piece of functionality over here, someone's working on this piece, and they're all different, and you've got a big mess to unravel. And the longer it stays there, the worse that becomes. So that's where automation comes in. Obviously, in the pipelines, we want to add things like linting, static analysis, unit tests, auto build, and Matt's talk this morning talked a lot about how you set some of that stuff up with a new Laravel project. But you're not always starting a new project. You've got legacy projects where you don't have this set up, and that can feel like a really heavy lift. How do you get all of that process easily into a project that's already, been there or, been going on for years and has thousands of, code files and that sort of stuff? Where do you start? Lint is a good one, a good place to start. So, Matt also made another really good point. He said that you shouldn't argue for styles. For code styles, just adopt a standard. And, that's absolutely right. There's no point in, arguing over whether curly braces go beside parentheses or on a new line. Just pick a standard. What matters is that it's consistent, because that's the thing that's going to help prevent you spending time resolving issues with white space. In Laravel, again, we've got some nice new nice tools there. We've got things like Pint. And if you're implementing this into an existing project, you don't have to, go back and spend all that time up front cleaning all of your code. you can implement your lint rules and say, use the dirty flag, right? And what that means is every time you make a commit and you run this as part of your pipeline, it will check any of the code files that have changed in that commit. You can do a similar sort of thing with PHP CS. You can set a baseline, and what that does is it looks at all of the lint errors in your code and immediately lists those out and says, don't worry about those right now. We'll put those aside. So with that, you can just drop this in and get going, and every new piece of code you write will have those lint rules respected. And you can set a business rule, every time you make a merge request, you can, fix something in that baseline file and slowly reduce that over time. And so, gradually over time, you'll improve the quality of your code base that way. Static analysis is the next thing. Static analysis is super helpful. It can help you find issues in your code before they even cause a bug. So you can do a similar thing when you're setting this up in a new project, right? You can set a baseline of static analysis issues, and same thing, implement a policy where every merge request or every pull request improves on that baseline over time. Automated testing. It can't be said enough. Automated testing is critical. But again, it can feel like an overwhelming job to go back onto a big project and implement automated testing. But you don't need 100% code coverage. In fact, that's not even desirable because you want your unit tests to run quickly in your pipeline. You don't want them to take, 15, 20 minutes to run unit tests because you want to get that feedback as soon as you can. If you can cut your unit tests down and make them efficient, make sure they're not calling databases or not calling external services, you can keep those, have a really robust test suite within sort of 5 minutes or less. Migrations, we've talked a little bit about migrations today. Really important because with migrations you can not only speed up the review time because your developer can check out your code, or your reviewer can check out your code and run those migrations, get your database into the right stage without having to write all that up. Again, putting that in, if you've got a big existing database, you don't want to have to spend a week, going back and writing migrations for your existing structure. So just use artisan schema dump and get a snapshot of where your database is now and start writing migrations for everything going forward. Seeding, this is my favorite kind of seed, but database seeds are the next best thing. Again, you've heard a little bit about this today, and it's, if you've got a really good set of seeds and factories, you can use that in a lot of different ways, right? You can use that for load testing, just quickly spin up 10,000 or 1 million records and use that while you're doing your reviews. But you can also, once you've got all of those pieces in place, you've got your migrations and your seeders, you can start to automate setting up a review environment as a part of your pipeline. So when you raise a merge request, it actually deploys a review environment that your merge reviewer can just click on. They no longer have to check out and set up on their local environment. They can just test it straight there in the browser and do code review straight there in the browser. So, once you've got these things, you've got this nice visibility on your issues, and you're doing all of that work up front. That stuff happens automatically. It's not going to a reviewer to go and check those things and then write it up and come back to you. You can get that feedback within 5 minutes of making your commit, of raising your merge request, and you can get feedback while it's fresh in your memory, and you can fix it straight then and there without having to context switch. Some other things worth looking at. Now this, you'll probably note, has a hallucination, but I really like the idea of AI code reviews because it really does speak to that. If you can get like a sensible initial review of your code without anybody else having actually looked at it, you can deal with those issues again while they're fresh in your mind. So this is something that I encourage you to watch. We also use Danger.js, and that's to kind of help improve like the workflow stuff. So things like labels, making sure labels or time entry, the right cost center is on your issue, so you know where to record time if that's your gig. And that can save you, having the right labels on an issue can save you from completely missing that thing is ready to review. Okay, so you've got everything there. You're ready to merge. And merge with continuous deployment means a deploy. But how does that stack up with minimizing the code that you want? You almost want to commit things that are unfinished so that other developers can get their hands on it. Right? So this sort of situation where you've got people trying to build the roof while the walls are being built. And we want to do that in code because you can get insights from your other collaborators, from the other team members who are trying to use what you're building. And, but how do you do that and still deploy to production on every merge request? Feature flags. I'm really passionate about feature flags. This is really powerful because you can build code and your first merge request can actually be just adding the feature flag, add that logic gate, and turn it off in production, turn it on in development, and you can actually deploy that straight away. You're not actually making any real code changes, and that's a really low-risk deployment. And once that feature flag is off, you can make your commits, you can keep them small, you can hide them all behind this logic gate, and you can still work on them in development or enable them in your testing environment. And it's a really kind of powerful thing. When you get, we use Unleash, and when you get to the point of actually deploying, let's say you're deploying to a large user base and you want to be sure that your infrastructure isn't going to fall over because of the change you made, has some hefty database queries. You can gradually roll this out. You can maybe make a beta cohort in your database and key your feature flag to that and enable it just for that single cohort. Or you can roll it out to, say, 10% of your users or 50%, and you can kind of ramp it up. And you can see, once you've started using feature flags, if you enable a feature flag in production and something goes wrong, you're not having to actually roll back your application. All you have to do is disable that feature flag because that previous version is what was already running in your production environment. So you know it's solid, you know it's stable, and you can just turn it off. So that really helps you with this decision. You no longer fear the deployment on Friday because you know it's just a simple job to disable that feature flag if something is going wrong. A key part of that, which I haven't touched on yet, is observability and metrics. The obvious things like your standard measures like your CPU usage, memory, all this sort of stuff, your latency, time to first byte, that's all great. You should also have really good coverage of your business metrics and track those as part of your observability platform. If your key product, if the key thing that your application is doing is selling some product, right? If you make a deployment and all of a sudden your product sales take a dive, you can roll that back, and you can even hook that up to roll back automatically. And this is how GitHub manage their own deploys with gradual rollout and automatic rollback based on metrics. So you can sort of see now that these organizations with a really high DevOps maturity how they can achieve those results of 5% failure rate and less than an hour, typically a few minutes of being able to recover from those failures. One other thing to track, and this is not related to deployments necessarily, but track how long you're spending on planned versus unplanned development. That will help you sell the culture change, and hopefully your culture doesn't look like that. But this can help you give some real data to back up what you're doing. And what you should see is that you're spending less time on that unplanned development and more time on that planned development as you improve your processes. And that can really help bring leadership and management on board. And you can also use these kind of tools and technologies to really explain the safety and the confidence that they can give you. So a really good example of this is Macquarie Bank. Macquarie Bank is obviously, financial institution, and there's significant, they have significant risk if something goes wrong with an update to their systems. But despite this, they have a gold standard of having new hires deploy to production on day one. Now that shows real confidence in their systems. That's awesome. And imagine the boost you get as a new employee deploying to production on day one. That's really cool. So if there's one thing that I want you guys to think about is, how can you implement this kind of incremental improvement? What's the next thing you can do to improve your CI/CD processes? Thank you.
Great. Thank you very much, Sam. Well, just a couple of quick questions for you. When we are talking about recovery from failure, how do you define recovery? Are you just doing a rollback?
Yep, so recovery could be either patching the issue or rolling back.
Okay,
yep.
Cool. How can you push, I suppose this is a question from Connor, how can you push within your organisation for more regular automated deployments?
Sorry, say that again?
How can you push for more regular automated deployments?
Yeah, that can be a really difficult thing to do, and one of the struggles is actually bringing the development team along for the ride and trying to get them to commit smaller, less risky deployments, smaller, less risky things to deploy. So once you've kind of got that piece of the puzzle sorted and you've got the kind of quick rollout and the feature flags part of the puzzle, you're taking a lot of the risk out of the deployments, and you can really show that via metrics that you're tracking.
Great, amazing. Thank you very much, Sam, for a second year in a row.